Next, we're going to introduce a set of graphic displays of basic statistical description data. Earlier, we have looked at a box plot. It is a graphic display of 5-number summary of a univariate variable, which is very useful. It's used very widely. And next, we're going to look at quantile plot, quantile plot, and a bar chart and histogram. We're going to compare the difference between bar charts and histograms. And lastly, we're going to look at scatter plot. So a quantile plot displays all the data. It's similar to the, it represents similar information as the box plot, but it actually shows all the data points. So how do we plot a quantile plot? So here in this example, we have unit price of a set of products. So from $0 to $140. And we will sort all the prices in order. So the data is sorted in increasing order. Then for every data points, we compute what percentage of the data is smaller or equal to this value. So the first, we have $40, and nobody, I mean 0% of the entire data is smaller or equal to, well, when we consider equal, yeah, it's a very tiny small percentage. So we can use, this is the first value, 40 is our first value, divided by total number of values we have. That will give us the percentage of the items that's below or equal to the value of x of this, the first value, 40. And for the second value, again, we can use 2 over total number of values that we have to find what percentage, roughly what percentage of the data are below or equal to the second value here. So we can use this pair of values to plot this plot. So you can tell that the x-axis actually is the percentile. So by looking at a plot like this, we will be able to tell that Q1 is around here, maybe around $60, and the median is 50% percentile, right? So the median is roughly here, probably $80. And the Q3 is here. So it's very similar, the minimum value and the maximum value. It's very similar to 5-number summary and box plot. The only difference is that you can actually see the individual data points. The plot will always have an upper pointing trend because the data is sorted in the increasing order. However, because of the value, there might be a gap between two consecutive values after sorting. So you might have vertical gaps, but you will never have horizontal gap. The way that this percentile is computed, there are quite a number of variations. So this is a basic idea, you know, what how many data points is below the current data points that you can easily compute using this. However, to make sure that the first plot is not right on this dot or just the ending point, there are different variations. Those really doesn't matter because quantile plot is just a visual exploration for you to see the pattern of the value distribution. The Quantile plot is actually fairly rarely used alone. The most common usage for a Quantile plot is actually plot a Quantile plot. The idea, so a Quantile plot plots a univariate variable. So it plots only one value of only one variable. But a Quantile plot graphs the quantiles of one univariate distribution against another univariate distribution. So if you have two univariate distribution, so think about here we have unit prices from one branch of a store, and the unit prices of all items, assuming they sell same set of items, in another branch. We can plot a quantile plot to compare whether their distribution is the same. You can also plot one univariate distribution against another known distribution, for example, a sample created using normal distribution. In that case, you will be able to tell whether this univariate distribution is actually normal. So the idea is so we will sort the values from all the unit price from branch 1 and branch 2. This graph, okay. Then we will pair those values up. So the lowest value from branch 1 is paired up with the lowest value from branch 2, and that's our first data point. And then we use the second smallest price from branch 1 and plot it against the second lowest price from branch 2, and that's our second data point. So this way we can actually our data points will be plotted in this two-dimensional space, and if these dots actually form a straight line, that's the indication that these two distributions are identical. So these two samples are from same populations with the same distribution. So in this case, we see they're almost straight, but not quite. There is a curve quite notably here. So we can see the unit price of the items sold at branch 1 tend to be lower than the unit price sold at branch 2. So this is example that we have two. We don't care about the real distribution of these two unit prices from two branches. We care whether they have same distribution. QQ plot is more typically used in a situation where you plot an unknown distribution to a known distribution. Imagine this, we could actually plot unit prices from branch 2 against a known normal distribution, a data set from a known normal distribution. If again we get a straight line, then that suggests that unit price from branch 2 follows a normal distribution. So this would be called quantile normal plot. That is used more often than the single quantile plot. So the next set of plots that we're going to talk about is bar chart and a histogram. The example in the book, the histogram example in the book, to me, it's basically a bar chart. I think I stick to the classical definition of histogram. Bar chart is quite different from histogram. So I provided this little table here to clarify the differences. So a histogram shows the probability distribution of a given variable by depicting the frequency or density of observations occurring in certain range of values. So one example of histogram is this, where we plot amount of transactions. So 60 in our shopping carts analysis, we see that 60% of the transactions cost $0 to $1,000, and 20% of our total transactions cost between $1,000 and $2,000. So this shows how the dollar amount spent per transaction and the density. We can see majority of the customers spent less than $1,000 in a transaction. A box plot, a bar chart looks like this, where you have the x-axis can be basically anything. And here the histogram, the y-axis could be frequency or density. It can be either a count or percentage. And in a bar chart, the y-axis can be anything. So in this case, it might be price. It can also be count. So go back to summarize the differences. Histogram is used to plot continuous variables, which we see here. There is not a gap. The value is not, it's one continuous value. This is another histogram that the y-axis is actually count. So count the frequency of something occurs. The gap, because histogram plots continuous variables, there is no gap between the bars. Bar chart, because A plots discrete variables, therefore there should be gaps. So in this case, we have nominal variables here. So the payment type, check, credit card, debit card. There is not a relation here. You can't see check is more or less than credit card. So there is a gap, and there is not a semantic relation when you look at the values in the x-axis. When you have just a nominal data, you might have ordinal data that creates an order, but in any case, because it's not continuous variables, there should be gaps to indicate that the values are not continuous. And the bar width, in histogram, the bar width is actually meaningful. In bar chart, because the nominal discrete nature of the chart, bar chart are often equal width. So each bar, the width of the bar is the same. The example that I depicted here all have equal width, show equal width histograms. However, as we're going to learn later, we can have different width. We could have equal depth histogram. The order of the bars for histogram, because it's continuous variables, the order certainly matters. It's from small to large in any case. but for bar chart, because it could be nominal values, therefore the order does not really matter. You can put cash in front of check. That does not really change the semantics of the graph, the meaning of the graph, what the graph tried to depict. Okay, so this is the difference between bar charts and a histogram. Another point we want to make is the histograms can tell more information than box plots. They give you the entire distribution of the data points. The two, so in this example, the ideas we want to illustrate is that box plots probably sometimes would be an overly simplified summary. In this case, this two distribution, we can tell it's very different. This one is a bimodal distribution. This one is more of a normal distribution with with a unimodal characteristic. Here, if we look at the 5-point summary, they're the same. The minimum value is the same, maximum value is the same, median is most likely the same, the average is the same, and the Q1 and Q3 could all be the same, yet the distribution is very different. Tracking histograms would be helpful than just looking at box plots in order to see distributions of a univariate variable. A univariate distribution, right? So the last plot that we're going to look is the scatter plot. So earlier we have univariate numerical data to plot. We can using box plot, using Quantile plot, using histograms or bar chart, depending on your data types. The scatter plot is a way that you can actually look at the bivariate numerical data. And this plot is going to show you patterns, correlation, outliers, clusters. So it's a very powerful tool when you have bivariate data. So the data consists of two variables. So in this case, we plotted a set of observation which are products. So each product has a unit price, but it also has number of items sold. And we can plot these two variables along x and y axis. So this data point is one product which costs $40 per item, and we have 300 items sold within a week, for example. So this plot will show us, looking at this pattern, we see that the lowest, the least expensive and the most expensive items are all sold at a smaller amount than the items that has a price in the middle range. We don't see a direct correlation. It's not the cheaper the item is, the more we sold it, because this trend is not straight, it bend down at a certain point. When it becomes more and more expensive, it sells more, but after a certain point, when it becomes more expensive, it's starting to heading a downward trend. And so you can also see clusters and outliers, not depicted in this picture, but you can imagine something could happen here. So that would be an outlier. So because this is a bivariate data set, each data point is represented by two values, which give you the number to plot the coordinates for x and y axis. Okay, so we saw this pattern when we plot a bivariate data set. We could also see other patterns. So this is another plot that shows whatever x and y axis variables are, they have a linear correlation. So this correlation is positive. The greater the values in x-axis, the greater the value in the y-axis. We have, in this case, negatively correlated, linearly correlated data variables. So whatever the axis variables and y-axis variables are, the patterns that we see here is the greater the x-axis variables, the smaller the y-axis variable. And we can also, the pattern that we see earlier, this is also, the data set shows very strong correlation, but it's not linear. So it might follow another correlation, but we see fairly clearly there is a correlation. Okay. In contrast, if you have uncorrelated data, when you plot scatter plot, you're going to see something like this. It's more random. We don't see a trend. The data seems to be quite uniformly distributed within a certain areas that our data covers. So this, when you plot like this, you can see the data tells you that those two variables are not correlated. Okay, I'm going to stop here for this topic. I will start a new video for the next topic.